When I'm interviewing a candidate for a development job, one question I like to ask is, tell me your least favorite thing about your favorite programming language. Well, today I'm going to answer that question myself. This is 10 things I hate about Go. Hi, I'm Jonathan Hall. Today I'm talking about things I hate about Go. Haters gonna hate, right? Well, don't get me wrong, I actually like Go a lot. It's my favorite language, it's my go-to language these days. But there are, of course, things I don't like about it. And that's why I like to ask that question in job interviews. I think that if somebody can articulate the things they don't like about their favorite thing, that shows a certain depth of knowledge and understanding that I like to look for. So today I'm going to talk about 10 things I don't like about Go. Now, I recently did another video about 10 things I do like about Go, my favorite things about Go. You can find a link to that up here or in the description below. If you're a regular viewer, you've probably already seen that. If not, be sure to hit subscribe so you get notified when new videos come out. And check that one out after this one. Now, before I dive into my list of the 10 things I don't like about Go, I want to talk about one thing that's not on my list because it's something that a lot of people bring up all the time, especially newcomers to Go. And that is Go's verbose error handling. Now, if you've ever used Go at all, you've probably run across something that looks a little bit like this. This is a very typical, repetitive Go error handling chain. You call a function. If it returns an error, you check for that error and must return. You do the same thing over and over and over again. This is a very repetitive pattern in Go. And newcomers, even myself, when I was new to Go, complain about this all the time. Try to find ways to simplify and sort of dry up your code a little bit. A lot of people hate this. I don't anymore. I've come to actually embrace this. I actually like this style because I think it adds to the readability of the code. I know it feels foreign to newcomers, and of course there are some very mature Go developers who would disagree with me, and that's fine. You know, there's always room for opinion. But in my view, the extra expression, the extra explicitity that comes from this style of error handling actually improves developer productivity because the alternatives of like doing throwing an exception or something like that are kind of magical, and it's not always obvious what's happening in your code. This way, it's explicit. It's always obvious what's happening with your error handling. So I actually have come to appreciate this. So that's not on my list today. Let's get into the things that are on my list, the things I don't like. Number one, exported package variables in the standard library. Actually, I don't care if it's in the standard library or a third-party library. Either place, they're bad. But this happens a lot in the standard library, and I don't like it. So I'm going to talk about what I mean. So there are a number of places in the standard library, not to mention third-party libraries, which is another story, where exported variables are exposed and used. I don't like this convention. I'd probably go so far as to say I don't think it's ever appropriate. I can't think of an example where this is necessary, and it introduces unnecessary problems, which I'll get into here. The basic problem with exported package variables is they can be modified at runtime by any package in your program. You can modify them, which can be powerful in some cases, but so can any library that you import, even a third-party library. If you pull in some package that you haven't vetted, you don't know if it's doing appropriate things, it could potentially be changing some of these exported variables in the standard library to do who knows what. Now, if you come from a language like JavaScript or Perl, you might not think this is a big deal because there you can kind of change anything at runtime you want to, and you just kind of don't by convention. So if that's where you're coming from, you might not think this is a problem. But Go is a statically typed, strongly typed, compiled language, and the expectations are, and I believe should be, different with this type of language. So let's look at just a couple of examples of what I'm talking about here. There are many common error types defined and error values defined in the standard library, but probably the most ubiquitous one is io.eof. And this is how it's defined. It's defined as errors.new and the string eof. It is an exported package variable. What that means is that you or anybody else can change this value at runtime. So here's a very simple program. I just set io.eof to be my own error value, and then I can print it out on io.eof. Now it's not EOF anymore. Now, you might be thinking, okay, but if I change that to something else, as long as always check against io.eof, I should still have equality, right? Yeah, probably so. I mean, if somebody changes that, it would probably not do a whole lot in this case. But there are other error values in the standard library. Error file doesn't exist or not exist, for example, and so on and so forth. You could change it. At minimum, you could change the error message to say something completely ridiculous or deceptive. Worse, you could start a Go routine in the background that changes this every 5 seconds to something completely different. Who knows what you could do? It's kind of dangerous. Now, I've never seen that actually happen in this case. I'll talk about in a moment cases I have seen happen, but I've never seen these error values actually be redefined. But I'm sure it could happen. It probably has happened. But the fact that it can happen, I think, is ridiculous. There's no reason to do that. Let's look at another example. This one comes from the net/http package, and the variable is default client. This looks pretty innocent, I think, at first. Default client is defined as a pointer to an empty client instance. Seems reasonable, right? I've actually seen this one go wrong. Now, it's common if you're just doing simple scripting type stuff in Go to just use the default client by calling http.get, for example, which uses the default client. The problem is when you start to set things on there. So let me show you an example of how this could easily be done accidentally. It can be done intentionally too, but it can easily be done by accident. And let me show you. So have a look at this code. It's actually a very simplified example, but this is an example of something I've seen, and it's common. It's easy to have happen. So I have a function here called do something that takes an HTTP client to do something with it, and then it sets the timeout value on that client. Now, I would assume the author of this function, if it weren't me just 5 seconds ago, expected this to be not the default client, but in this case, it is called with the default client, you see. So I'm setting the timeout value on the default client in the standard library. That means if any other package that I've written or have imported anywhere else in my program uses the default client, it now has this timeout set. If I have set this timeout to 10 seconds in one case and 60 seconds in another, whichever one gets called last takes precedent. So it's actually very simple to accidentally set the values on the default client in the standard library without even realizing you're doing it. You could also do it intentionally. Maybe you want every use of the default client in your program to have a 10-second default timeout, or to use a different transport, or whatever other settings you might put in there, TLS configuration, etc., etc. Maybe you want that, and maybe that's fine for a simple self-contained command line tool, for example. But if you do that in a library, which I've also seen done, you're making assumptions about everyone who uses your library that they want the same default settings that you're using. So just don't do that. To work around this, I actually never use http.defaultClient. I never use it. I always use the explicit version. I always do this. That way, I never have any opportunity to accidentally use a default client that isn't what I expect because some third-party library or myself accidentally made this change. Aside from that specific fix in this case, what can be done about this? Well, I have two general suggestions. Of course, that's not the topic of this video, but just really briefly. For the error case, I prefer using constants. Don't use, if you need to export an error value from your library for some reason, use a constant if possible. There are other ways to do that as well. You can do interfaces and so on, but I'm not going to talk about that today. Constants are a simple way to solve this specific problem. And then the way to solve this problem for the example of the default client in the HTTP package is to make it a function rather than a variable. It can be a function that returns the default client. So I would much rather have http.defaultClient be a function that returns an instance of the default client rather than to be a variable. There, of course, are some limitations to that. I mean, if you intend to set the default client for your entire program, that won't work anymore. I think that's a bad practice. I don't think you should do that, but it would mean that that particular pattern couldn't be done. In my view, that's a reasonable limitation, and in fact, a good limitation. Let's move on. The second thing I don't like about Go, since we're talking about the HTTP package, is that the HTTP handler doesn't return an error. Let me show you what I mean. So HTTP handler is an interface defined here. It has a single method called serve HTTP, and that takes two arguments, a response writer and a request. normally, in fact, always, I guess, you read off of the request. Maybe you read some data from the body, or you look at the request parameters, the path or query parameters and so on. And based on that, you produce a response and you write it to the response writer. But there's no error here. If you have an error, not found or permission denied or whatever, it's your responsibility as the implementer of the handler interface to write a proper HTTP error to the response writer. I think that makes sense, more or less, from the standpoint of HTTP, but it doesn't really match the way the rest of Go works. It's actually very cumbersome to do error handling in an HTTP handler if you're using the standard library, especially if you have different middlewares or different layers of your stack that you need to have your error bubble up. Your flow control is no longer tied to your errors the way it is normally. Now the HTTP package has the error function. You can see that here, which makes this a little bit easier for you, kind of. It takes a response writer as an argument, an error string, and a code. So you can easily say, I want to return the phrase file not found with code 404. It's really very limited in its capability, though. Normally, for most types of errors, you want to do something a little bit more than that. Like if you have a 500 error, maybe you want to display a description on the screen that's friendlier to your user than what this will do. So this really is not a very useful function. And even if it were, it doesn't really solve the problem that I'm talking about, which is coupling error handling and flow control. In most Go programs, when you have an error, you return it, right? We saw that at the beginning. And that is an indication to stop processing the rest of whatever might be happening in that function. That doesn't work in the HTTP handler case because there's no error to be returned. So you have to manage this some other way, and the standard library doesn't really define what that way ought to be. So you end up kind of reinventing the wheel in some way. Now, if you're using a Go framework for web, most of those solve this in one way or another. LabStack's Echo has a handler that returns an error. I think Revel does. Many of them do. Of course, many people don't like to use a full-fledged framework. I'm one of those people, and it's kind of an ongoing debate in the Go community: should you use a framework or not? A lot of people say the standard library does everything you need. Almost, it doesn't do this. If you're interested, I have written a library. It's kind of experimental, although I've been using it in production for a while at a few different places. That tries to solve this problem and this problem only. Now, this package is called Ale. It's at gitlab.com/flimsy/ale, and it basically adds new versions of the HTTP handler that solve this particular problem. So I've added a new handler interface that has the serve HTTP method on it that is exactly the same as the standard libraries, except that it has an error. So what that means is if you return an error, then that stops processing. And then, of course, you have to define what to do with that error, and this library makes that easy. You can define a specific error handler that turns that error into a message you send to the user. If you're interested, have a check on that library. It's open source, free for anybody to use. That's my answer to this particular problem. Number 3, no pointers to literals. So enough about HTTP. Let's talk about a general language feature that I find annoying, and that is that you can't create a pointer to a literal or a constant. Why would you want a pointer to a literal, you might be thinking? Well, when you phrase it like that, yeah, who would want that? But actually, it's pretty common, and there's one particular answer there I want to look at. So this question actually comes up pretty frequently on Stack Overflow and probably everywhere else that Go newbies go to ask questions. And what it is like, so you can see here in the example, in the question, there's a struct with a field that is a pointer to an int64. It could be a pointer to just about anything, any basic type, an int, a string, etc. And you want to assign that to a pointer to 0, for example, as the example shows. This is not valid Go. Why not? Well, you can't create a pointer to a literal. And 0, in this case, is an integer literal. Or to a constant, for that matter. If you had defined this 0 as a constant called foo, you can't just do a pointer to a constant either. Now, there are several ways around this. And we can see a lot of them on this answer. This is a great answer on Stack Overflow. Of course, the link is in the description. But you can use the new function, which creates a pointer to the 0 value. If all you want is a 0 value, you're golden. Just use new. Usually you don't, though. If you want a pointer to an actual value, though, like say 2, as we've seen in this next example, then the new function just won't work for you. So you need something else. One option is to use a helper variable, and this is probably the most common answer I see done. So you define a new variable. In this example, is called helper. You set it to the value 2, and then you take the pointer to that. That's what's done here. That's very easy. But it's an extra line of code, which is kind of annoying, and an extra variable that you otherwise don't need. You could use a function. So you could create a function. In this case, it's called create, or maybe you want to call it pointer to int, or whatever you want to call it. And it takes an argument of the specified type and returns a pointer to that. It's pretty straightforward. Now you have, now if you're using that frequently, it's just one line to invoke that function each time, but you have to create that function, which is annoying. And prior to Go 1.18 with generic support, you had to create that function for every type you cared about. Another option is to use an inline anonymous function. So you can create and invoke the function at the same time. That way it fits on one line, but it's a really ugly line. So here you can see we have this inline function called func. It doesn't have a name, it's anonymous. We have this inline function that returns a pointer to int64. Inside that function, we create a variable called I. We assign it the value 4 of type int64 and return the pointer to I, and then we invoke that function immediately. Slightly shorter version of it is to take an argument of that type and then just pass that in. It saves 4 or 5 bytes of typing. And another option, the one I usually have gone for, is a slice literal. And the only reason I go for this is because it's shorter, although it's possibly more confusing. And that is so to use an inline slice. So in this case, it's a slice of int64 with a single element in it, the number 5, and then we pull out the item at index 0, and then we take a pointer to that. This is confusing if you don't know, if you aren't already familiar with it. You're going to look at this and go, what the heck? Another option is to use a struct literal, which I've never done this, and I don't think I would ever want to. But you could create a struct with the type, and then take a pointer to the field, which is what's going on here. And an anonymous struct literal, same concept, but making it anonymous. I think that's even more confusing and long and blah. Good news is, in Go 1.18 and newer, we have generics, so we can do this much simpler. Now we can create this single function. In this case, it's called PTR with a capital P, so it's exported somewhere. You put it somewhere in your program that anyone can access it, and it takes an argument of any type and returns a pointer to that same type. Now, so with generics, this will work with any type, with strings, with int64s, with int8s, with whatever. Maybe this will be added to the standard library at some point, and then it will be a completely non-issue. But that's where we are now. Honestly, I think that they should make an exception and just make this part of the language so that you can do it as makes sense and just do like an @0, and it would do what you expect. It would just inline create a variable of that type with a value 0 and point to it. I think that would make sense. I understand why they don't do that, because they're trying to explicitly not hide complexity. But I think that this is such a common case that it would have been worth it to just make an exception and make that part of the language. Now that generics are here and we have this one function approach, adding that to the standard library is probably good enough, and we can just call this one a day. Let's keep going. Loop variables. Oh my goodness, this is annoying. All right, if you've been using Go for any amount of time, I'm sure you've run into this. Let's talk about loop variables. This simple program demonstrates the problem. Now, it looks like it's fairly straightforward. We have an original slice that contains 3 elements, 3 strings, 1, 2, and 3. Then we're ranging over that slice and assigning to a new slice that is a pointer to string, a pointer to each item. So we would expect normally for the result after this to be that PTR contains a slice of pointers to the strings 1, 2, and 3. But that's not what we have here. If we run this code, you'll see that the output is 3, 3, 3, not, as expected, 1, 2, 3. What's going on? So for some reason, long ago, back in the pre-Go 1.0 days, they decided, I guess to save memory, probably, that when iterating through a for loop, we would reuse these two variables. The first one in my case is the blank identifier, so it's not there, but the second one is what matters here. So rather than reallocating a new variable for each iteration of the loop, we use the same variable. So when we take a pointer to that, we're actually pointing to the same memory address every single time. So on the first iteration of the loop, it's a pointer to a particular address in memory, and 1 is copied into there. Then we go to the second iteration of the loop. It's the same address in memory, but now 2 is there. And then on the third iteration, 3 is there. So we're actually copying the same pointer into this new slice every time. That's why, and then when the loop exits, that pointer is set pointing to 3. That's why when we print the pointer 3 times, we get 3. This is also a problem if you invoke a go routine inside of the loop, because the value passed to the go routine might be updated by the next iteration on the loop before the go routine finishes. So this is a big problem in Go. The good news is there's discussion these days about possibly changing this. Technically, it's a breaking change in Go, which would break the backward compatibility guarantee of Go 1 that we hold so dear. However, considering that this practically always results in bugs and never what we want, there's a strong incentive to change this, even in Go 1, without waiting for Go 2, which may never happen. If you're interested in the discussion on this, it happened in October, I believe, of 2022. You can find that on the GitHub discussions for Go, item 56010, and there's, of course, a link in the description below. So this may be changing. I would love for it to change because it's one thing that it just is never helpful and it's very frequently harmful. Moving on. Let's talk about naked returns.
They're naked!
And their returns. What's a naked return? A naked return is allowed in Go when you have a function signature that declares names on the return values. In this case, I have I and error. Once you do that, then those values are already initialized to their 0 values at the invocation of the function. You can set them to other things if you want, as I've done here. But the key is that you can just call return without specifying the values that you normally would. Don't ever do that. It never adds clarity to your code, and it frequently hurts readability. I wish this wasn't a feature of the language. This is perhaps the biggest misfeature of the language, in my opinion. So in summary, don't use naked returns. Next on my list is relative imports. So Go doesn't actually support relative imports. Well, except that it does. Well, sort of. What is a relative import? Let's talk about that, and then we'll go on. So relative imports are imports that contain relative paths in them. You can see a couple examples here. This is not actually supported, really. So here's the thing. The Go spec doesn't prohibit these. The Go spec actually says that the import path's interpretation is implementation specific. So it is, in principle, possible that a Go implementation would interpret this correctly. And in fact, there have been some that do. In the past, these were more common than they are now. With the advent of Go modules, the support for this has been, if not completely removed, largely removed. But it certainly was possible to do this at some point in the past, and it probably still is for certain tools. I would love to give you a complete list, except that would require looking that up, which I haven't been able to find. I did actually look for it, and I'm not willing to go to the effort of trying all the Go tools to see which ones work, which ones don't, because the bottom line is don't ever do this. Just don't do it. I wish that all the Go tools all the time gave you an error when you tried to do this. It's improving. It's gotten better. There was actually a bug in Go 1.18 RC2, I think, that allowed relative imports in certain circumstances. They fixed that. But historically, this has been more or less possible in some cases. These days, it's still possible in certain cases. There's also a closely related problem. It's not technically a relative import, but I'll bring it up since we're talking about it. So technically speaking, an import statement like this, foo/bar, is meant to reference the standard library because there's no host name in it, right? However, you can get around this and kind of use this as a relative import if you define your GoMod module name to be foo. Let me show you what that means. So GoMod defines the name of your module. If I change this to foo, then this is now referencing a package called bar within my module. Don't do that either. Please don't do that. Use proper host names, full paths to your Go modules and your packages. Let's move on to a favorite one. gofmt's format. In my previous video about things I like about Go, I mentioned gofmt. I love this tool. It just eliminates so many arguments about should we use tabs or spaces, curly braces, or blah, 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 whatever. That's over with. I love it. But you know what? I don't like the format.
gofmt style is nobody's favorite.
In fact, I've always been a spaces guy, not a tabs guy.
I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
And you know what else I hate about gofmt's format? Let me tell you.
Who cares? Shut up.
Moving on. Let's talk about comment directives. So the Go compiler understands a certain number of directives, and these directives enhance usage in certain ways. The two most popular ones, the ones you're most likely to have seen probably, are build tags and embed directives, although there are others. Go generate uses directives, and there's a few others. Some are fairly archaic. But they look like a // the word go, and a colon. Let me show you. So here's a very simple build directive that says that this file should be included when compiling for Linux. Now these directives are great. I don't have any problem with the directives. They're great, they're powerful, they serve really useful purposes. What I don't like is their format. They are comments, for goodness sake. Now I understand why they're comments. That way certain tools can just ignore them because they don't matter to those tools. But I really wish they'd given this some other syntax. Maybe they could use a double plus. Or put them in parentheses. Or, I don't know, use a shrugging emoji. I don't really care. I just wish they weren't comments, because they look like comments, but they're not comments. I hate that. But that ship has sailed. Number 9, array and slice terminology. One thing that trips up practically every newcomer to Go, myself included when I was new, is this concept of arrays versus slices. Now, every language has this concept of a list of things. Most languages call that an array. Some call it a list, whatever. But Go is weird. We call them slices. But it's worse than that. It's not that we just call them something else. It's that we also have arrays, and arrays are different. In Go, an array has a fixed defined length of, say, 6, whereas a slice has an undefined length. I mean, it has a length at a moment, but it's not fixed. It can grow or shrink. I wish they had renamed these to something else. Let's call them arrays and fixed length arrays or something, but it's just annoying and kind of embarrassing that we have this concept that every other language has, but we just call it something slightly different. And oh my gosh, all the Stack Overflow comments about, oh, you're not asking about arrays. Isn't that annoying too? All right, so here we are at number 10, and I'm really kind of scraping the bottom of the barrel here. I actually started writing this list of things I don't like about Go several months ago. And, you know, the first 5 or 6 were pretty easy to come up with. I really hate naked returns. Comment directives annoy me. This loop variables are just ridiculous. But I didn't come up with 10 for quite a while. And this one, yeah, it's kind of a stretch, maybe. And honestly, this one isn't really a feature that exists in most other languages either, unless you're using a purely functional language, maybe Haskell or Rust or something like that, which I'm really not very familiar with. But I kind of wish, I think it would be nice if Go had some way to indicate when a function is a pure function. So first, what is a pure function? A pure function is a function for which the output is determined solely by its input and there are no side effects. In other words, it doesn't read or set global variables or state of any sort. It doesn't talk to a database. It doesn't read the time. It doesn't use a random number generator. It doesn't set any of those things or read them. One simple way to think of a pure function is you could easily cache the results because the inputs, you know, whatever arguments it takes, directly control the outputs. There's no other variables that matter. It's a pure function. And I think it would be cool if in Go you could indicate that a particular function is a pure function, and then the compiler would fail if you tried to read or set global state in some way. I think that would be cool. And now that Go has generics, we're so much closer to this true functional paradigm, it wouldn't be that difficult of a mental jump to get there. Now, I don't know what's technically involved. It probably will never happen in Go. If you really want those sorts of safety capabilities, you can use Rust or whatever. But But I think that would be fun. I would like to see that in Go. I'd like to see more functional paradigms available to us as Go developers. And I think that will start to happen even if this particular feature doesn't quite make it. Well, there we have it. 10 things I don't like about my favorite programming language. What are your thoughts? Did I leave off something that you don't like about Go? Leave it in the comments. I'd love to know what you think. And if you enjoy this content, you might also enjoy Boldly Go Daily, my daily, 5 days a week email list on the topic of Go. If you're interested, head over to boldlygo.tech/daily, and there you can subscribe. And of course, be sure to hit like and subscribe, and I hope to see you here again. Until then, boldly go.